Today we are going to see about waveform distortion and distortionless lines. Guess what the image indicates? Distortion. Signal transmitted over lines are normally complex and consist of many frequency components. For ideal transmission, the waveform at the line receiving end must be the same as the waveform of the original input signal. The distortion requires that all frequencies have the same attenuation and the same delay caused by a finite phase velocity or velocity of propagation. When these conditions are not satisfied, distortion exists. The distortions occurring in the transmission lines are called waveform distortion or line distortion. The types of distortions are frequency distortion and phase or delay distortion. Frequency distortion. When a signal having many frequencies are transmitted along the line, all the frequencies will not have equal attenuation. For example, voice signal is a complex waveform consists of many frequencies. Hence, the received end waveform will not be identical with the input waveform at the sending end because each frequency is having different attenuation. This is called frequency distortion. When the attenuation constant is not a function of frequency, frequency distortion does not exist on transmission lines. In order to reduce frequency distortion occurring in the line, the attenuation constant should be made independent of frequency and by using equalizers at the line terminals which minimize the frequency distortion. Activity. Phase distortion. When a signal having many frequency components are transmitted along the line, all the frequencies will not have same time of transmission. Some frequencies being delayed more than others. So the received end waveform will not be identical with the input waveform at the sending end because some frequency components will be delayed more than those of the frequencies. This type of distortion is called phase or delay distortion. And the methods to avoid delay distortions are: when velocity is independent of frequency, delay distortion does not exist on the line. The phase constant beta should be made independent of frequency. The velocity of propagation is independent of frequency. A transmission line is said to be distortionless when attenuation constant alpha is frequency independent and the phase constant beta is linearly dependent on the frequency. Conditions for line to be distortionless: R by L equal to G by C. Assessments. References. The assessment questions is given as: transmission line is distortionless if option A RL equal to 1 RC, option B R by L equal to G by C, option C RL equal to RC, and option D RL equal to RLC. The correct answer is R by L equal to G by C. Second one, the distortionless line is one in which the attenuation constant and phase constant are independent of the frequency. State true or false. Answer is false. Which two parameters given below are 0 in the lossless line? Option A L, C, option B C, G, option C G, alpha, and option D R, L. So the answer is option C, G, comma A. References. The topics are taken from J.D. Ryder, Networks, Lines and Fields, and Raju, Electromagnetic Field Theory and Transmission Lines. Thank you.